Hi, everyone. Thank you for joining the Deeper Dive webinar. It's now 1:02 Eastern, so we're going to go ahead and get started. My name is Nagin Aftab, and I'm the Senior Partnerships Growth Manager here at Losant. Today, we have a very special webinar for you, the first of its kind. One of our partners, KST Technologies, is here with us. From their team, Bob Crescent, their CEO, and Devin Saavedra, their UX UI engineer, will be going through the application template they built using Losant's platform. Myself and Teron Foxworth, our education lead, will also be here to answer questions at the end. Before we get started, I want to address a couple of housekeeping items. This webinar is being recorded and the replay will be made available to you in a few ways. After this webinar, we'll send you an email with a link to the replay. Additionally, the webinar will be made available on Losant's YouTube page as well as on our Deeper Dive webpage. Throughout the webinar, you may have questions that you'd like to ask. I would like to point out a couple of key features in the Zoom conference. You can use the Q&A feature or the chat function to post questions, and I'll be monitoring those throughout the call. At the end of the call, I'll moderate a Q&A session with the posted questions. If you have to leave early, no worries. The Q&A will be posted as a PDF alongside the replay link. Let's do a quick review of Losant and our enterprise IoT platform. Losant is an application enablement platform. What that means is that Losant provides enterprises with the building blocks to create their own IoT applications. Our platform consists of 5 key components to help customers achieve that: edge compute, devices and data sources, data visualization, the visual workflow engine, and end user experiences. Our customers and partners utilize these tools to create the robust IoT applications they put in front of their end users. Losant is a leader in the industrial, telecommunications, and smart environment spaces, and we've offered this platform for all sorts of customers, ranging from startups to companies in the Fortune 100. So if you're interested in learning more, please reach out and we'd be happy to set up some time for a much more in-depth conversation. Now, let's get into today's deeper dive. Trash to Treasure, a KST Technologies application template. While Losant provides the software foundation for IoT, there are many other components that have to come together to create an IoT application. So we've surrounded ourselves with a great ecosystem of partners. This includes strategic partners with whom we share sales and go-to-market strategies, solutions partners who work with clients to develop end-to-end IoT applications, and lastly, technology partners that can provide hardware, connectivity, and other services to complete an IoT solution. That's where KST comes in. In March, we released significant functionality to our platform, application templates. These are pre-built templates that help a customer get their application to market more quickly. In previous deeper dives, we have showcased asset tracking, equipment monitoring, overall equipment effectiveness, and multiple other templates. If you've kept up with Losant's growth, you'll know that our template library, including the full-fledged application templates, are a pivotal new part of our IoT platform. Our vision is to make the process of creating end applications as easy as possible, which is why support from our partners is crucial. As we've continued to build out application templates, we've also asked our partner ecosystem to contribute, primarily technology partners like KST Technologies. Partner application templates are meant to simplify the integration process between Losant and our partners. This means having vendor-specific device recipes, workflows, and dashboards that make getting up and running much easier than ever before. Leveraging the integration work Losant and our partners have already done helps you get your project started and finished even quicker. Today, we'll be discussing the application template that KST Technologies has built. This application template is now available for you to import into your application. Just click Add to create a new application, and you'll see KST's Trash to Treasure application available. Now, I'm going to turn it over to Bob Crescent to walk us through KST Technologies, their offerings, and show off the Trash to Treasure application template.
Thank you so much, Nagin, and thank you for joining us, everyone. My name is Bob Crescent, president of KST Technologies, and we're really excited to talk to you today about how you can turn your trash into treasure using KST's technology as well as Losant. KST has actually been shipping distant sensor technology since late 2017, And almost since day one, we have treated our partnership with Losant as something really special. And it really makes the data that our sensors create come alive. And so we're totally excited to show to you today a Losant application template that would let you get started in your own IoT journey. So along the way, we're going to answer a couple of really key questions. First, we're going to take a look at distance sensors in general. And we're going to ask ourselves some key questions about what can be solved with them. It actually turns out that distance sensors are all around us. You may be using them every day, and you might be surprised by some of the applications that we've seen over the course of the last 2 or 3 years or so. Distance sensors, like any other sensor, does have its own nuances. And so second, we're going to explore the question, what are some important considerations for distance sensors themselves? What makes them unique? We'll also couple that with a very brief discussion about IoT sensors in general and some of the things that you should think about as you scale. Third, we're going to take a look at how data flows from device to cloud. We're going to start at the super high level, but then we're going to drill down specifically into the KST 3320, our own distance sensor, and how that data gets eventually to our Losant application template. Devin's going to take it over from there, and he's going to show you how we created a Losant application template that grabs that distance sensor data and solves some of the key stories and problems associated with IoT data. And then finally, we're going to leave you with some challenges, maybe some homework, maybe some quizzes and things to think about what you could do with your own IoT journey. And we're really excited to see what you do with this application template. So let's get started. You may not know it, but you are surrounded by distance sensors probably every day of your life. You may be using them and you may not even know it. There's some common use cases out there that are really popular. So if you've ever gone to an international airport or to a major office building, you may have seen these faucets that are automatically triggered by your hands. In some cases, those are simple IR sensors, but we've actually discovered in the field that sometimes those are distance sensors. And a distance sensor allows that application to be much more efficient, to know exactly that someone's hand has entered and then have left that particular area. Or maybe you have a more modern iOS or Android smartphone, and it has a time of flight sensor in it to help you get that perfect photograph. So you know exactly how far that subject is away, and that distance sensor can assist you with that. Or maybe you have a smart car and it's got sensors embedded in either front or the rear bumper, and it helps you to make sure that you don't accidentally hit someone when trying to execute that really complex parallel parking that we all struggle with. Those are examples of distance sensors that are all around us, and they're very precise. They've gotten less expensive. And so we've been able to leverage those markets in order to create our own distance sensor that we've been able to deploy. So there may be a couple of other examples that are kind of get your juices flowing in terms of what you can do with distance sensors and with our Losant application template. So here's a few examples of what we've done over the course of the last 3 years or so. Imagine that you've got this big tote of water and it's out in the middle of nowhere. And it's really important that that water level be known and that people can take action based on it. We've actually had certain KST customers grab a KST 3320 and embed it in that cap and then distribute this tote to the field. And they can detect water level. Or imagine that you have a rock salt softener. This is actually a picture from my own basement. I've got a rock salt softener and I've got a KST 3320. You can kind of see it there peeking its head out and looks down into the rock salt level. But every 2 or 3 months, I always forget and I have to put rock salt in this thing. But now I don't have to forget because Losant reminds me, and we can change our consumption rate and it tells me that I'm getting low, which is a really great application. So in the first example, you saw the example of measuring a liquid. In this example, you see something like measuring a solid. And maybe there's other really important things that you care about, like making sure that your toilet paper doesn't get low. This is an example of a KST 3320 looking at a toilet paper roll in the restroom here at KST. It actually turns out that distance sensors work really good for understanding whether or not toilet paper rolls are running low or whether or not your paper towels in your dispenser are running low. And that can become a huge dissatisfaction point, especially for major companies or airports. And so it's awesome that we can use the power of Losant and distance sensing to know how to take care of those things. And we've got a few more ideas. Now, thanks to COVID, we care very deeply about not only room utilization in office spaces, but just do we have too many people in the same place at the same time? And what's awesome about distance sensors is we can use them as really intense people counters. So we could measure, for instance, how many people are in a conference room, or perhaps how many people are in an entire office building, or perhaps just a floor, or maybe a corner of a retail store. These things are all possible with distance sensors. We've even had a partner take a KST 3320 and mount it to the bottom of a manhole cover, then replace that manhole cover and look for sewage. I know it's really a glamorous application, but a practical one. You don't want sewage to overflow. And so the RF problems here can be tricky, but it can actually be done using a distance sensor, which is another really practical application. You may have been in a parking structure, and it may be that that structure tells you where open spots are, which is really cool. But in some parking structures, you can't embed the sensors that normally go into the ground. We've actually had folks take KST 3320s and mount them in the ceiling, looking down instead of up, to determine whether or not a particular parking spot is full. Or perhaps you've worked in a factory, and sometimes factories have bins of stuff that work their way throughout a particular workflow. And sometimes you just need to know when certain bins are full or not. Maybe you need to dispatch an operator to take care of it, or maybe that's telling something about your production line. A KST 3320 or any other distance sensor for that matter is great at measuring things like scrap and then letting operators know about it. We've even had applications in warehouses where people have installed a KST 3320 to see how many pallets exist in a certain bay, or whether or not a pallet full of product is getting empty or not. And in some cases, even measure how quickly is that product running out, which is awesome. And so we can use the power of a distance sensor coupled with an IoT platform like Losant to really make that application sing. We've even had people come back to us and say, I need to know how many cardboard boxes are on this particular shelf at this time of day. And when it gets below this particular number, I need to order more. It's a super practical problem that usually involves a lot of manual work. And in this COVID world, that can get even more difficult depending on how many people you have in your back room. And so it's really cool that we can use distance sensors to solve that sort of problem. All that is great, but one thing that's near and dear to my heart is trash. And what we would love for you to do is open your mind and get your creative juices flowing a little bit with what you can do with distance sensors. But we found that about 80 to 85% of our KST 33 series devices go into the humble trash can. It's actually a great use case. Typically, a trash can gets emptied at a synchronous point in time. Like at my house, it's every Friday morning by 7:30 a.m. And that works, but what if we were on vacation and I don't really want to pay for someone to empty it? Or what if mine overflows 5 times over because we're cleaning the basement? I'd want someone to come out and empty it more frequently. It's just a very typical, great use case of this types of distance sensor. And so throughout today's webinar, we'll be showing you examples of how we use the KST 3320 and our Losant application template to solve a variety of those types of problems. So let's dig in a little bit deeper into the KST 3320 and how it integrates with Losant. At a super high level, whether we're talking distance sensors or accelerometers or temperature humidity sensors, we love to break our IoT data down into 3 key things and key 3 actions we can take with it. Sometimes we just want to measure that data, but more often than not, we want to interpret that data. And even most importantly, and of highest value, is to apply that data. So let me give you some examples of what we mean by each of these verbs. When we're measuring data, we may have a distance sensor. We may see a distance like 608 millimeters. That's pretty interesting. And it's really cool that a distance sensor can tell me that. And it's even more awesome that our Losant application template can show that to you in real time. But it's not very meaningful to me. I don't really know what actions to take with it. And so it's more important to think about how I interpret that data. Now, if I know that a bin is of a particular geometry and I know where my sensor is mounted, I can actually do a little bit of math in the cloud, and we do that in our Losant application template, and we can interpret that data. It's far more meaningful to know that my trash bin is 46% full, as opposed to knowing that the nearest trash is 608 millimeters away. So interpreting that data is even more valuable. But what's of the greatest value is when we can take some action, some meaningful action on that data. So imagine now that I could say, if this trash bin exceeds 50%, I want to send an SMS message to truck number 17 because truck number 17 is closest, and I want truck number 17 to take care of this particular trash bin. Once you've applied IoT data, the true ROI and the true value really comes into the forefront. What we really love about this Losant application template that we're about to show you is that we can measure that data and we can show you those instantaneous results. We can write JavaScript functions that bolt onto a Losant workflow that interpret that data and tell you something very meaningful about what that trash bin is going through. And we can apply that data using our Losant application template and workflow by sending SMS messages to people who really need it, who can take care of that particular problem. So it's really exciting that Losant application templates really scratch the itch and the need that we have to both measure, interpret, and apply IoT data. So let's dig in a little bit deeper about distance sensors specifically. When we talk about distance sensors, we find that there's really 4 key properties of a distance sensor that allow us to select it. We think first about its maximum distance. So there are 2 main types of distance sensors out there that we're talking about that can range and give you specific measurements. And those are typically either laser-based or ultrasonic-based. We found that laser-based devices like the KST 3320 have a great range from anywhere from 0 to about 4 to 5 meters. However, if we need to see beyond 4 to 5 meters, we found that ultrasonic sensors are really the way to go. Sometimes they have a maximum distance up to 20 or 30 meters. The only encouragement I give you about maximum distance is to be sure to optimize that and measure the object that you're trying to measure in order to apply the data. In other words, if you don't need to see the full 30-meter length of an entire grain silo, maybe you don't want to put in a 30-meter type of distance sensor. So think really carefully about that maximum distance. You also want to be able to see the bottom of a trash bin, for instance, as depicted in this picture. The second thing that we'll want you to think through is the resolution of the measurement. The KST 3320, when looking at a solid flat object, has about a 1 to 5 millimeter resolution. When it's looking at a typical surface with roughness, it might be around 10 millimeters. If it's connected to a water tank and that water is bouncing around quite a bit, then that effective resolution really drops, sometimes on the order of magnitude to a centimeter or 2. So you have to think very carefully about what resolution of measurement do you require such that you select the right sensor, and all sensors have different capabilities there. The third thing to think about, and that's depicted by this gray triangle in our picture here, is what we call field of view. This is basically what the sensor can see. Whether it's an ultrasonic sensor or a laser-based sensor, there's a certain field of view associated with it. Our KST 3320 is actually programmable. It's laser-based, and it varies somewhere between 15 and 25 degrees. But you can imagine if that field of view were bigger, that cone might actually hit the sides of the bin that you're trying to measure. And if it does, then it simply won't be able to see to the bottom. So it is very important to give some careful consideration to what that field of view is like. And finally, we encourage you to think about something called dead zone, which is basically the minimum distance that your sensor can see. In this particular case, if the KST 3320 is mounted on top, and if it's laser-based, it actually has a 0 millimeter dead zone. You can literally put your hand right on top of it, and you could read that your hand is right on top of the sensor. But if you have something like ultrasonic, that dead zone may be on the order of magnitude of tens of centimeters. That may be totally fine, as long as you go in eyes wide open when trying to figure out what sensor is right for your particular application. Now, as long as we're talking about IoT sensors, there's also 3 really important other considerations that we would encourage you to think about. The first is power consumption, and we like to break that down into measurement as well as communication. So imagine that you're taking a whole bunch of distance measurements. You might not want to push every single one of those to the cloud because you're going to pay a pretty heavy power consumption price. You're going to pay for every measurement, and you're going to pay for every uplink or transmission to the cloud. Instead, you may want to take maybe 15 to 20 measurements and maybe average those. And if the standard deviation is less than a certain amount, then you want to push that final chunk of data to the cloud. So think very carefully about power consumption, whether it's distance sensor or any sensor for that matter. You should also think about whether or not you can control that IoT sensor in the field. In the case of the KST 3320, we do support downlinks. So a really common scenario for our customers is to start off by pushing a lot of data to the cloud. And then they realize, yeah, the trash can really doesn't change that much over the course of an hour period. How about we just do 1 measurement an hour? The nice thing about the KST 3320 is you can send that downlink to the device, and then you can change its uplink, which is really great to have that level of control. And this is fully integrated into Losant. We can support downlinks that communicate directly to our sensors. And finally, for any sensor, whether it's a distance sensor, temperature, humidity, accelerometer, whatever it might be, try to give some thought to IP rating. In other words, what kind of water could get into this system? Could it be submerged, for instance? You'll want to pick the right IP rating for the job to make sure there are no surprises. All right, let's get a little bit closer now into what that data looks like in our Losant application template. At a super high level, we always think of the IoT in a very simple diagram. And there's really 3 players or 3 actors in that diagram. First is the sensor, in this case, the KST 3320. Second is the gateway, and it's really the glue that allows that sensor data to get to the cloud. And then third, there's the cloud itself, which typically stores and then represents data. That's where all the really cool measure, interpret, and apply actions can really take place. Now, in this case, we're going to show you LoRaWAN in the case of KST 3320, and that's our communication mechanism. But imagine that that gateway is cellular. Maybe AT&T owns that gateway. Or perhaps it is LoRaWAN and you're using a public LoRaWAN network like Helium. Or perhaps you have a private LoRaWAN network. Maybe it's activity-based like we'll be showing you here during this demo. Or maybe you have a simple BLE gateway that you have in your office and you're routing sensor data there. The beauty of Losant and what we love about Losant is that it's hardware agnostic. Doesn't matter if you're pushing from any of those gateways, you can ingest that data in any way that you need it. All right, let's drill down one more layer before heading into our application template. If we take that simple diagram and think of it in terms of the KST 3320, what we're specifically going to show you today, imagine that you have a device, our KST 3320, that communicates with a basic LoRaWAN network server that's physically located within about 1 to 3 miles of that KST 3320. It receives that packet data and then forwards it to the cloud, either with a 4G backhaul or maybe over a Cat5 interface. There's then a cloud component that determines whether or not that KST 3320 is commissioned and then what it should do with the data. In our case, we actually forward the data to an application server that we run that we call Covalence. What we love about Covalence is we could have any number of IoT devices feeding data into Covalence, and then we can packet that data in whatever way we want, and then we can push it to a critical platform piece like Losant. And so that's what we're doing in our demo. But imagine now that you want to scale to hundreds or tens of thousands of sensors. Maybe you don't want covalence in the middle, and that's absolutely no problem. The beauty of LoRaWAN or cellular or Sigfox or whatever it is that you're playing with is that you can get those packets eventually to Losant without the need for that middle ground application server. What we love about Losant is that it is a developer-friendly, production-ready solution. So whether you're pushing one piece of data to the cloud from one sensor or 10,000 sensors of all different manufacturers of all different types, it is enterprise grade, and your Losant application template can totally grow with it. So that's a brief overview of distance sensors, how we get data to the cloud, what kind of problems distance sensors can solve, and some of the really unique challenges and things that we've seen over the last couple of years as we've built Losant-based applications to solve our customers' problems. At this time, I'd like to turn it over to Devin. Devin is KST's UI UX engineer. He's been working with Losant for many years now, and we've built all number of dashboards. And as our UI UX engineer, Devin has the job of working directly with our customers and figuring out exactly what problem they're trying to solve and how to display it. He's been the mastermind behind our Losant application template, and I'm totally excited now to turn it over to him and have him show you what he's been up to. Thanks, everyone. Devin, it's all yours.
Thanks, Bob. So as Bob mentioned, my name is Devin, and I'm KST's UI UX engineer. So today I'm going to walk you through our application template that we created for our 33 series distance sensor. To start, I'm going to go back to one thing that Bob talked about was the measure, interpret, and apply. So here you can see we have a graphic of a bin, and we have our 33 series distance sensor. So as Bob was saying, yes, we can measure and get the distance. Say this is 1,000 millimeters. Maybe in the middle it's 500. But that's just a raw number. We need to interpret that into something meaningful, like he was talking about as well. So to do that, we need to know the height of the bin. And then if there is a gap, if you have your sensor above the top of the bin, we need to know that as well. So with those two numbers there, we can then calculate, say, the fill level, fill percentage. So then we can easily interpret the fill level for you. So that's a little more powerful and meaningful than just a raw number. 75%, you're getting pretty full. You're going to need to apply a notification, tell somebody to go out there and change it, empty it, or whatever it is you need to do, depending on your application and what it is you're measuring. So with that, I'm going to jump into a dashboard that we've created using the application template and show you exactly what we can see. So here is one of our dashboards. And you can see we have our distance in millimeters and in inches. Then we've interpreted that into a fill percentage here. So in this particular application, we're only 12% full. That's good. So we're not overflowing, or we don't have any issues there. But that way it's a quick glance to see where we're at on this particular sensor. So along with these three blocks we have here, we also have our battery percentage block. So you can see the battery state of the device itself. And since our 3320 has GPS sensor built into it, you can see exactly where in the world it is. So here we have a map showing the last timestamp and location of exactly where this device is, which is currently at our office. Above that, we have another block just showing the last payload with a timestamp, along with the device name, and again, distance in millimeters, inches, percent, and also RISI and SNR. We'll talk about these just in a little bit. So we scroll down and see a couple other blocks we have on our dashboard. We're showing historical distance in millimeter and in inches. So you can see here that it looks like we were kind of had some trash in this trash can, and we got a few more in there. And then it looks like it got emptied, and we're back to a relative state, 12%. And we're showing that again just in inches, in case you don't like millimeters. So then here we have our historical signal strength, RISI. This is a really good tool for troubleshooting. So in case you have a real deployment out in the world and you're on the hairy edge, say, of your base station or gateway, you would know exactly which devices need to be closer, or if you need to get another base station closer in range of those, so you get better data transfer. Another troubleshooting issue you can look at is the SNR, the signal to noise ratio. So with all that, we're going to jump into what the application template is and how to use it. So when you add an application template, the KST33 series distance sensor, you're going to get presented with this view. And you'll see that there's one device, a simulated device. We got 3 dashboards, a dashboard that we just looked at with real hardware, which we'll look at again later on. And we have a couple of simulated dashboards. So since our 3320 has not just distance sensing on it, we have GPS, and we also have a 3-axis accelerometer, temperature and humidity. We can actually simulate all these so you can see exactly what they'll look like. And then to do all that, we have our 2 workflows, one for real hardware and one for our simulated device. And we also have this great README down here. So anything that I may miss, you can come here and read, and this will cover everything that you need to know. So a key thing that Bob mentioned as well is Covalence Application Server. So that takes these webhooks that we provide for you, you include those into your LoRa network backend, which then pipes the data to the Covalence Application Server and just standardizes on it. So even though our sensor itself conforms to Cayenne low power payloads, each network server can change the attributes or the payload type, maybe just the wording, or using a camel case, using a space versus an underscore. So we just take that and just standardize on all of it. So then we just feed one same payload back to Losant or anywhere else you need to go. So with that, we're going to jump into how to create a device. So we have our 2 device recipes. We have one for a simulated device, so you can create multiple devices, and we have one for the real hardware. We're going to look at the real hardware one, and I'm going to show you just how to add a device. It's really simple. So we go to devices, and we'll go to create from recipe, and we'll choose our real hardware recipe. And we'll create from recipe, and you're presented with this. So now I have a real device. So if you had your device set up ready on your LoRa network server, and then you would just take the dev UI, put it right here, take the serial number of device, put it right here, and that's it. You're ready to start receiving data. So to see what some of that data looks like, we have set up all these attributes. So these are all the things we're looking for in the payload. So we're going to look for our battery, look for our location, distance. We're going to convert the raw distance from millimeter to inches. And then we're going to take the conversion that we looked at earlier, the bin graphic, do our fill level. We're going to use our dev UI as our identifier of the device, so we know exactly what device to show in the dashboard. And here's just a bunch of other little things that we'll touch base on a little later as well. So the carrier, what network provider it is. Here's our LPP packet, so we know what packet to look for. And so let's jump into a workflow and see how this all works. So like I said earlier, we have 2 workflows. We have one for a real device and one for a simulated device. So let's start with a real device here. So we've done our best to add notes and comments to every single node within the workflow. So if you're just starting off with Losant, you'll know exactly what to do and what each of these are doing. And when you first add the application template, you'll automatically get a webhook. So in this particular application, you'll have 2 webhooks. You'll have the ones that we provide in the README that go onto your LoRa network backend. And then you have one that Losant creates that you'll need to send to us at KST, and we'll apply that to the actual device you have so we know to route it back to Losant. So you'll automatically get a webhook already here, and all you have to do is copy that and send that to us, and you'll be good to go. So next down here, we're going to look to see all of our different things. So we're going to check to see on a conditional node here to see what the LPP type is. So we're going to see if it's distance. We know that 82 is distance. So if we see that payload, awesome. We're going to grab that, and then we're going to do a math node here and convert the raw millimeters of distance to inches. And then we're going to take our fill level. So what we talked about earlier, interpreting the actual measurement that we get, we're going to do a little JavaScript here. Let me zoom in so you can see a little better. So based on that graphic, we had our height above our fill line, which could be nothing. It could be a gap. It just all depends on your application. So in this particular one, we have it at 280 millimeters away. And then we need to know the total distance that you're measuring. So for this, we're just doing the distance to bottom of 620. This could be 4,000 millimeters since we support up to 4,000, or it could be less. It could be anywhere in between. It all depends on your application. So to get the percent fill level for this particular application, we just change these two numbers and that's it. So knowing that, we're good to go. And if it's not distance, we're going to go ahead and check to see if we got our LPP type of 88, which is GPS. So if it is GPS, we're then going to carry on and concatenate using a string node here to look for our location of latitude and longitude, and then just dump that into our payload of location. Along with that, we have another math node here that we're going to take the altitude from meters and convert it to feet. And lastly, if it's not distance or GPS, it's going to be our battery payload. So we look for LPP type of 78, and we get our battery. And then we have our device get node here. So this is why it's important to enter in your dev EUI. So this is how we identify your devices, and we can easily return multiple devices. In this particular instance, we're just looking at one, but you can easily scale to hundreds or thousands. Here we're just doing a quick check to make sure that the device actually exists. So maybe you added it into your LoRa network backend, but you forgot to add it into Losant. So we just do a quick check here to make sure that you've added it into Losant so you can actually see it. And we got a debug here. So if you didn't, we'll give you a message of device not found. So that's kind of a hint that you need to add it to Losant before you can start seeing data. If it does exist, then we're going to go ahead and grab all the attributes that we kind of went over. So all our attributes for our device recipe directly correlate to our payload. So we can see our distance is going to be piped to payload.distance, and so on and so forth. We get all our little nitty-gritty attributes here that relate directly to the payload itself. And we have another debug down here, along with a GPS debug up here. These are great, and I'll go into a debug panel in just a little bit when we look at the simulator workflow. These are just nice so you can quickly kind of search for GPS or just a generic debug to see everything in case you have any issues arise when you're out troubleshooting out in the field. So with that, let's look at our simulator workflow and get a little deeper into some of the debug panel and just how you can simulate a device without actually having real hardware yet, and get a dashboard up and running just to see how it looks and play around. So with our simulated workflow, it's a little different. We've added notes and comments to everything just like before, but instead of a webhook, we have a timer. So every 15 minutes, we're going to fire off this workflow and we'll get new data. Our default for our 3320 is normally through LoRa is 15 minutes. But like Bob was saying, maybe you need it to be, every hour. You can easily change that to once an hour. But for simulating, it's just fun to change it to anything you like to get more data or less data as you need it. So then we're just going through each node. We're going to do a random number generator for our battery. Do the same for our distance. And then we're going to do another math node to convert from millimeters to inches and also show our fill percentage. So even though we're using a JavaScript function in the real workflow for real hardware, here we're just using another math expression. It's the same concept, but here's where you would change your height above the fill line, and here's where you would change your total distance, the height of the bin or whatever it is you want to measure. Then again, just a random number node for our RISI, SNR, along with temperature, humidity, and with the temperature, we're converting Celsius to Fahrenheit. And location, we're doing a mutate node here and just hard coding in our lat and long and then piping that into our data location. And since we have an accelerometer, we'll do a random number from -8 to +8 on all 3 axes. And then we're just going to look for our one simulated device. So we don't need to know the dev UI or anything like that. We're just going to select our one device that we have, and we should be good to go. And we have our debug node here. So debugging is super powerful inside of Losant because then you get to see exactly what the payload is that you're getting. So whether you're going directly from your LoRa network to Losant or through KST's Covalence application server, you'll see what the payload gets in here and if there's any issues at all. So here we can see we have our data, our accelerometer, Z, Y, X, our location, humidity, which will be shown as %, temperature in Fahrenheit and in Celsius. And then we also have our SNR, gateway SNR, and our RISI, our fill level, our distance in inches, our distance, and our battery. So it looks like our distance right now is at 2,293 millimeters. So let's look at the simulated dashboard so you can see the correlation there. So we got our distance there. And we have our distance right here, exact same number. So within this block itself right here, we're showing the distance in millimeters. And if we go back, we can see that we got 90.275 for inches, and we got 90.28, so we just rounded it up. Awesome. So we have a few more other blocks here. So it's a little more compact of all the blocks we have versus the normal real hardware one, just showing distance and fill percent. So then we can see we have another block for our temperature in Celsius and in Fahrenheit. We have our humidity as a %. We got our battery %. Here's our fill percent again. And here's our accelerometer. We're showing all X, Y, Z axis, all 3 axes here. It's a little sporadic. We're just simulating data, so you wouldn't hopefully see that in real world applications. But if you had the accelerometer in use and using it, you could also set up thresholds and you can apply something. So say if your trash can tipped over, super windy day, starts blowing around, or there's a bear that knocks it over, something like that, and you got trash all over the place. With this, you actually get notified if you by applying a threshold to this and send somebody out to take care of it. So not only can you send somebody out to see the fill percent when it gets to a certain percentage, but you may want to do that if you on a certain axis of the accelerometer, or maybe the battery's getting low, or if the humidity is too low or too high, or maybe the temperature, maybe there's a fire, or something's freezing and your device isn't going to work anymore. Along with that, we have our last known stats, just like in our real hardware. So we have our last timestamp here, and we're showing our device, saying that it's their simulated device. It's all the same data. We have our distance in millimeters, inches, % full, our battery, our RISI and SNR, and our accelerometer, temperature, and humidity. And again, we're showing the same thing, just historical distance in millimeters and in inches, and RISI and SNR, so everything matches up. So one thing that we can do within our dashboards itself in the workflows is to actually add in or apply. So we talked about measure, interpret, and applying. So applying something, so say we need to send a message. We can easily drag and drop an SMS node, and we'll plumb that into exactly where we want it to go into. So say if it was just on a certain threshold for, say, the fill level, we can pipe that in directly to our fill level here and maybe do a if at 75% the fill level is less or greater than, we can then send a message to somebody. You can also send other messages as well. So not just SMS. Losant has a great selection to choose from. You can tweet somebody, you could Slack somebody, you can set up Twilio and have an automated call go to somebody. So with that, I'm going to jump into another dashboard that we have here that Bob talked about in one of the slides, was our measuring toilet paper, any paper products in the restrooms. So here's the exact same dashboard as the first one that we saw, but I've just added in another block, an image block, so you can see the sensor itself. This can be helpful if you need to see the location of where the sensor was beforehand. So say you have multiple of these and you need an image here of saying this is in the east wing of an office space on the second floor restroom. So here, instead of we're showing fill percentage, we're going to show roll percentage. Just change the names of these things. It's still doing the same thing. We're still looking for the height above the fill line and from the top to the bottom of this application itself. So instead of it being a bin, we're just looking at the roll height. So here we can see we're at 79% full. So it's a decent sized roll still. No need to go send anybody out there to change anything. We're showing the battery and the raw distance in millimeters and in inches. The exact same stuff. It's just a different application. Instead of trash, it's a toilet paper. So we can apply here for the janitorial staff, instead of going on a scheduled routine every hour or every 3 hours, going around checking every stall, checking all the paper towel rolls. We can then just apply a notification when something gets low, or we think it's going to get low based on looking at our historical distance. So with that, I'm going to jump this back over to Bob to wrap things up.
Thank you so much, Devin. Now that I figure out how to use my controls, thank you for bringing us to the Losant application template. It's really exciting, just at a personal note. After working with Losant for so many years, to see that application template live is actually a really big deal for us. So the entire office was excited to see that. It's kind of the culmination of a multi-year relationship with Losant that has just been awesome. So great job, man. Appreciate you taking us through that. So let's wrap up. So where do we go from here? Now that you've seen a little bit of what distance sensors can do for you and a lot of what the Losant application template could do for you, where can you take it? So we've had customers over the course of the last couple of years see that initial Losant application template like dashboard and ask us to do a number of things. And what's awesome about the requests is we can do and satisfy all those needs through the Losant platform itself. And so one of the things that you might want to consider doing with our application template is figuring out how to extend it to more sensors. If there's time later during Q&A, I can show you how we've done that with a live smart city that's located in Georgia, where we needed to extend from their initial 2 to 3 sensors to about a dozen sensors. And so you might want to think through, how could you take this application template and extend it to more sensors? The good news is that workflow is completely malleable. It can be used in order to extend to 12 or 100 or even thousands of sensors, and we can get into that. Another thing that you might want to consider, and we have a lot of our enterprise class customers or Fortune 100 type customers ask this, is what if we wanted to bolt in our own custom data store? We've actually done this for clients where the data still flows to Losant, and we use Losant from a management perspective. But then they already have their own dashboards they've built, their own backends. And so we get to use the power of our application template to manage our own devices. But then they get the data in the way that they need it. So just like Devin showed you how to bolt on SMS, you can also bolt on S3 or any Amazon services as just an example. And that goes into Azure as well. And so if you needed to get that data into a custom data store, you could totally do that and use this application template as a great starting point. A lot of our customers also care very deeply about the health of the device once we deploy it. And so Devin showed you how our application template has this idea of signal to noise ratio, or RISI. We use that data in order to determine whether or not those sensors are healthy. So you might want to come up with your own algorithm. Maybe you want to say if the SNR changes by more than, say, 15%, in a device that is not supposed to move, maybe that's an indicator that a base station changed, or maybe our device is moving. Or maybe you want to look at RISI, and maybe if you see a 20 dBm difference day after day, that may be an indicator again of something wrong from a device health perspective. So you may want to bolt on your own health API to make sure that the devices are healthy. Or perhaps you want to see what would happen if you had thousands of these in the field without actually having to deploy it. What we love about Losant, and this is one of my favorite features that Devin showed you, is that we can literally simulate tens, hundreds, thousands of devices virtually before they even exist. We actually did this for a client who wanted to purchase up to 10,000 devices. And we warned them that if they're not used to that amount of data, it can be very overwhelming just to figure out how to manage that fleet. And so we built for them a Losant dashboard. We built 10,000 virtual devices. We had that up and running in a matter of no time with our application template as a starting point. And our customer was able to see that data, and they actually asked us to configure the hardware differently as a result, which is so cool. So again, something that you can do before you get too far into your IoT journey. We've also had customers come back to us and ask us to put on specific types of access control. So imagine a smart city scenario where you've got an IT manager. They probably want to see everything about your sensors. Or imagine that same smart city, you have a supervisor and he's responsible for a fleet of 15 different trucks. He'll want to see a different dashboard. Or perhaps you're an operator or you're a truck driver out in the field and you need to get those notifications. All three of those people need to see the data in a very different way. And what we love about Losant is that you can completely build those different dashboards for those different people, including notifications, to meet exactly the needs that they've got. And if you really need to get intense about it, which sometimes our customers do, you may even want to look at Losant experiences, which is probably a totally different webinar, but it's another way of interacting with the Losant platform and getting the exact type of customization that you need. We've also had customers say, this is great. I've got garbage data. I've got truck data from GPS. I want to integrate these and do an intelligent routing application. You can totally do that as well. In those cases, there may be a third party that offers a particular service like route optimization that you want to bring to the table. And you can completely do that with Losant and bolt on third-party algorithms or ML platforms to solve whatever you want. We really love to tell our customers that really their imagination is the only limit. If they can imagine doing something, we can probably do it, whether it's in hardware and also definitely with Losant and its flexibility. So there's a number of things that you might want to consider doing after you get a chance to create your own Losant dashboard and play with our Losant application template. And if you're ready to start playing with sensors, there's a way that you can do that as well. I mentioned that we've been shipping KST 33 series products since late 2017. And we're really pleased to announce that we've partnered with some of the most major IoT corporations in the world to bring a dev kit to you that scales to production quality. And so if you're interested, you can reach out to KST either at info@kstechnologies.com, or you can go to our website and go into our contact form and we'll answer your email and we'll give you more detail about how you can get a dev kit for yourself. In that dev kit is a single KST 3320, and that has the host of sensors that Devin talked about. We pre-commission that to a gateway from a company called Actility. They're a world leader here in the space, and it's a LoRaWAN gateway. That LoRaWAN gateway runs a private network server, and we can get that data then to the cloud and manage the device for you. And then, like Devin mentioned, if you send us some simple details about the Losant application template that you created, then we can forward data from Covalence to your application template. And later, if you want to scale that, you totally could. Our dev kits include a production quality KST 3320, a production quality Actility gateway, and we have options to go outdoor as well, and a production quality Losant application template that scales to the thousands. Like Losant, we have the same vision for the IoT, that a dev kit should be really friendly to developers, but it needs to scale at a production level as well. And with KST's sensors and with Losant's application templates, you have a platform to make that happen. So thank you so much, everyone. We've really enjoyed the webinar. I'm going to head and turn it over to Nagin now for a wrap up. Thanks, everybody.
All right, thank you very much, Bob and Devin, for showing off Trash to Treasure. We do have a couple of questions that have come in through the chat, and we'll get right to them after one last note. If any questions pop into your head, please make sure to put them in the Q&A section of the webinar software. We'll also provide a PDF of all of the Q&A, including some questions we don't get to in the webinar when the replay is published. If you do have questions about this webinar or as you're getting started on your Losant journey, we have tons of resources to help. Losant University is a great place to get started, and our thorough documentation and active forums are fantastic tools for help. For reference on applications we have built, check out replays of our past deeper dives, and if you're ready to start building, try out one of our hands-on tutorials. Now let's get into some questions. So the first question that we have is probably a good one for you to answer, Bob. Are the KST sensors battery operated, and what's the battery life of the KST33 device when reporting once per hour or once per day, etc.?
Yeah, that's a great question, Nagin. So our devices are battery powered. We actually ship by default with alkaline batteries, so they're very easy to just source locally and fairly inexpensive. We do warn that alkaline batteries work really great in indoor or in stable temperature environments. If you are like our Canadian friends to the north in a fairly intense weather environment, we do have options for thionyl chloride based batteries where the battery is actually sealed up inside the enclosure. From a battery life standpoint, it's a great question. So our middle of the fairway scenario is our default firmware. And our default firmware ships with one distance measurement that's done every 15 minutes. We push that data to the cloud also every 15 minutes, and we do that 24 hours a day, 7 days a week. Once a day, we take a battery measurement, and once a day, we take a GPS measurement. And in an alkaline battery in a room temperature environment, that's about an 18-month battery life. Now, that does scale a lot. So if you need more intense GPS, or you want to use the accelerometer to know that that bear tipped over that trash can, which has happened, if you want to know those sorts of details, then all that does take a power hit. And I really encourage you to reach out to us at info@kstechnologies.com if you have a specific scenario. We do have a battery profiler tool that we use. So we'll ask you a bunch of questions. We'll figure out what sensors you need to turn on and how often. And then we can give you a very specific profile of what we expect from a battery life standpoint. So great question. Thank you, Nagin.
Great. Our next question is, what would this look like managing a fleet of devices? And so I think that's in reference to the application template. And I think this is a kind of a multifaceted question that would be good to take from both a KST side as well as from a Losant side. So Bob, I don't know if you want to start out, and then Sharon, maybe jump in.
Yeah, I would love to do that. So I'm going to share a dashboard that's live. This is a dashboard that we created for a city, a pretty small city. It's a suburb outside of Atlanta. It's just northwest of Hartsfield-Jackson, named College Park. They have a downtown section. They've got about 12 different KST3320s that push data. And we started with our Losant application template and then scaled it up as they went from a few sensors to a dozen sensors. They're super friendly to us, so I appreciate them allowing me to share this dashboard with them publicly. But this is an example of what I would call just very light scale. In other words, you can see probably the exact elements of what we did to scale this from one sensor to about a dozen sensors. And this is where I'll probably turn it over to Losant to jump in and talk a little bit about experiences. So imagine now that you need to scale this from 12 devices to 1,000 devices. 1,000 trash icons gets really overwhelming to look at on a single screen. And sometimes we'll do that based on like the GPS map view, like you see here. And sometimes we'll go with a completely different UI. So I'll go ahead and turn it over to our friends at Losant, and they can add more about Losant experiences, which is probably where we take that next.
Yeah. Hey, just checking in. Is everyone able to hear me okay?
You sound great.
Okay, perfect. Thanks, Bob. I can fill in the gap on the experience side of things. You're absolutely correct. And the dashboard you showed was very beautiful, by the way. But once we get into thinking about our application from, okay, now we have this device, it's easily streaming data to Losant. Okay, where do we go next to add more devices? And then how does these devices automatically provisioned? The nice thing is that Losant has answers to these questions at different various parts of your application. So, and you've seen some of these elements already. So for example, in the walkthrough that Devin was going through, he showed the device recipe. Device recipes are one of the mechanisms in Losant where you can create that recipe and then easily use it to generate these new devices. And then now that we have that recipe, you can use Losant's workflow functionality to automatically use that recipe based on specific actions. And then the nice thing is, kind of wrapping all this up, since experiences allow you to create those applications for your customers, those experiences are also backed by Losant workflows, and you can use the experience workflows to build that auto provisioning and auto onboarding logic for your devices. And best of all, one of the newer features in Losant is a template library. Two of the entries in the template library that exist today that kind of can get you really a lot of those base components for these types of examples within Losant. They are called the device provisioning and dynamic registration. Those are the two templates in the template library that are really great examples for this type of use case within Losant.
Great. Okay, so we have another question here. To detect theft, can I set up geofences and get an alert if the device leaves a specific area? And I think this one would be a good one for you again, Tehran.
Yeah, this one comes again really in the workflow engine. So once you have data streaming into Losant and you're now able to act upon that data in the workflow, all the various nodes in the workflow are, encapsulations of functionality that you can now quickly use and leverage within your application. One of those nodes are the geofence node, which allows you to do just this. You can detect if a device is within a specific geofence within the platform and build alerts and notifications based around that.
Great. Okay. Next question. Are bears knocking over trash cans a common issue in your neck of the woods? Bob, I think this is a good one for you to take.
Yeah, so funny you say that. We have trash cans that are right outside KST, and you might have remembered the geo fence or the GPS map that Devin showed. That's actually where our office is. So we're in the middle of Black Forest, Colorado, which is gorgeous and surrounded by trees and bears and deer and dogs and all kinds of things. So actually our motivation for adding an accelerometer was to make sure that if a trash can did get tipped over, we would know it. And it works really well for that. But a few other crazier things have happened with trash cans over time as well. I mean, besides bears, we've had people knock trash cans over. We've had people steal trash cans. So for some reason, certain trash cans are mobile. We don't quite know why, but they are when they shouldn't be, which is kind of interesting. We had one smart city say, hey, we have a lot of dumpster fires. Can you detect dumpster fires? Like, wow, that's rough. What goes on that you have so many dumpster fires? But yeah, we can. We have a temperature sensor. So that was an interesting one. And the best one was when municipality asked us if we could smell how bad the trash smelled. You can't do that with the current KST 33 series, but there are actually electronic nose technologies that we've investigated that we could put into sensors for particular smart cities. So yeah, the bears can be rough out here in Black Forest, Colorado, Nagin. You're welcome to come out here anytime. We'll show them to you.
We will take you up on that, but I'm not so sure I want to see the bears, to be completely honest with you. So we are hitting, or we're just past the hour. We have a couple more questions that came in. I'll make sure that when we release the replay, as well as the PDF with it, that the answers to those questions are in there. One last thing I do want to hit on is that this template is available in our application today. So it is live. So if you go to your applications and click add, you'll see the KST template and you're able to play around with it, and you can purchase a dev kit from KST site as well. This is the first of many partner templates who hopefully that will be coming in the future. So we are really excited that you're here and with us for this webinar today, and hopefully you'll see many more. Couple of last notes. As we're hitting the holiday season, we don't have any deeper dives planned for the rest of the year, but we will pick them back up in January. So keep a lookout for our upcoming deeper dives and register on losant.com/deeper dive. Once again, look forward to this webinar's replay. If there were any questions we didn't get to today, their answers, along with all of the Q&A we didn't get to, will be provided with the replay. Thank you so much for tuning in, and we'll see you on the next deeper dive.